In previous class, dear students, we studied Newton's third law and its application. Just remind it, Newton's third law. This law states that every action there is an equal and opposite reaction. Let us consider two bodies A and B. Suppose force acting on A by B. Suppose force acting on A by B, which can be represented as like this. FAB means force acting on A by B. Similarly, force acting on B by A representation FBA means force acting on B by A. By Newton's third law of motion, we can write equal and opposite, that is FAB equals to minus FBA. Conclusion: suppose force acting on A by B. Suppose force acting on A by B is action. Then force acting on B by A is reaction. Action and reaction, a pair. Action and reaction, a pair. Conclusion: there is a single force either action or reaction. There is a single force never be exists next action and reaction. Action and reaction always exist in pair. Action, reaction exist in pair. Next, action and reaction are acting on two different bodies. Suppose a force is applied. Suppose a force is applied by this marker to the board. To the board. That is, this is a body and this is another body. Force acting on this board by marker action and board force acting on marker, that is reaction. That is action and reaction are pair. There is a single force never exists. Third one is action and reaction are acting on two different bodies. Next one is action and reaction never cancel with each other. Next point. Action and reaction never be cancel with each other, because action and reaction are always acting on two different bodies. If they are acted on a single body, then if nature is action and reaction are equal and opposite. If they are acted upon a single body, then they should cancel with each other. Since they are acting on two different bodies, therefore they never be cancelled with each other. Next one is no action occurs in the absence of reaction नहीं माने action नहीं. 1, 2, 3, 4, 5. These are very important points. All of you understand and also write yes or no. Students, understanding and also writing yes or no. All of you write. Next one is horse cart problem. Today we will study horse and cart problem. घोड़ा गाड़ी horse cart problem. Let us consider this is ground road. This is a cart. Connected by string. This is the position of a horse. This is cart. This is the position of horse. connected by string. Here, string due to force acting, tensional force, force of tension due to ground, opposing force, force of friction, opposing force, forward, backward, carefully, forward force, force of tension, backward force, force of friction, opposing force. Here also, in a previous class, we studied. In previous class, we studied while walking, while a man, while a man walking on the ground, that is action. Our feet is slightly slanted backward direction, backward direction, like this. Suppose this is a leg, slanted. While a man walking on the ground, that is action, our feet is slightly slanted backward direction. This angle is suppose theta, and this feet acting in force this direction. Suppose this direction. Dear students, clearly understand? Yes or no? This figure? Yes or no? Tell me. Yes or no? Here, action force, direction of action force. Here, direction of action, like this. Direction of action force, like this. This is ground. Direction of reaction, this is action, this is reaction. According to Newton's third law, every action there is an equal and opposite reaction. This is action, this is reaction. Suppose this is the ground, making an angle theta. This angle is suppose theta. Then we split two rectangular component this reaction. This is action and this is reaction. Since this angle is theta, therefore this component is r cos theta and this component is here r sin theta. Rectangular component split into two rectangular component. যার সেটা অ্যাঙ্গেলটা ক্রিয়েট করতে সেটা হচ্ছে cos, অদরটা হচ্ছে sin. Here this is our reaction, r cos theta, r sin theta. But here this is horizontal component. This is horizontal component, whereas this is vertical component. Horizontal component, vertical component. But here weight of the man acting downward. Here also weight of man acting downward. This is weight of man. Very interesting. Weight of man, that is W equals to mg, balanced with vertical component. These two are balanced, that is cancel. V equals to mg. Here F equals to R, action reaction. But here responsible factor for when a man walking forward due to component, horizontal component, that is r cos theta. Due to the component r cos theta, the man walking forward, that is only component, horizontal component. Here vertical component V r sin theta balanced with weight, action reaction balance. Here action, here reaction. Therefore, while a man walking on the road due to component, a responsibility component r cos theta, that is horizontal component. Like this, in case of here horse, like this, horse like this. This is vertical component. This is balanced with weight. This is horse h cos theta, vertical component h sin theta. H sin theta here balanced with weight, r sin theta balanced with mg, weight. Here also, in case of horse, vertical component h sin theta balanced with mg. As a result, horizontal component is here h cos theta. And this is also a string tensional force. Forward, backward, opposite. घोड़ार बेकरे जो दौड़ार लगी घोड़ा आगु जीवा चेष्टा करिवो फॉरवर्ड, तुम घोड़ा जो आगु जीवो कंपोनेंट रिस्पांसिबिलिटी फैक्टर होची होरिजॉन्टल कंपोनेंट, दैट इज h cos theta. h cos theta सिंपली h लेखो मतलब h, एटा जो फोर्स एक्टिंग होची घोड़ा आगु, दैट इज सपोज h. Here force of tension backward, but in case of car, this is tensional force forward and this is opposing force backward. Dear students, एतिके बुझेला ना बुझेला नहीं, एतिके आ बुझेला कि घोड़ा जो आगु तो जो फोर्स एक्टिंग करछि h, तार से जो दौड़ी लगी छी टेंशनल फोर्स बैकवर्ड. कार कड़ा एमती घोड़ा आगु बोले घोड़ा गाड़ी के आगु जीवो, घोड़ा गाड़ी के आगु जे माने स्ट्रिंग फोर्स रहला टेंशन, opposing force चक्का ग्राउंड से लगी छी, तो opposing force, that is force of friction, opposing force, that is F. All of you understand? Yes or no? Then for expression we can write horse and car problem. For expression we can write horse moves forward. Horse moves forward. You can say if h greater than t. स्ट्रिंग लगिले t लिखियो फोर्स टेंशनल फोर्स गोटे स्ट्रिंग लगिथो फोर्स ऑफ टेंशन टेंशनल फोर्स कैपिटल T here जदि this force is greater than this ताले आगु दियो के घोड़ाटा आगु दियो जदि ए फोर्स टा तो कमी गला ताले घोड़ा आगु जाई परिबो नाही therefore horse moves forward if h greater than t, that is if acceleration of horse be a, if acceleration of the horse be a, jati घोड़ा रा acceleration a and mass is small a, मने करो घोड़ा रा मास नियो तार वेट अछि मास माने वेट अछि w equals to mg और मास ता माने करो अछि घोड़ा रा स्मॉल a कार रा मास माने करो अछि कैपिटल a एटा का अचीव करो then we can say we know according to Newton's second law, then we can write according to Newton's second law, net force F equals to ma. This part already studied. It already पढ़ा है. Force equals to mass into acceleration. That implies here net force acting on horse. We can say here net force acting on horse. We can say, dear students, we can say एठारे net force acting on horse. We can say h गोटे फोर्स घोड़ा पर पड़ जाए आगु को आ गोटे फोर्स घोड़ा पर पड़ जाए पछु तारे नेट फोर्स केते h minus t फॉरवर्ड पॉजिटिव बैकवर्ड नेगेटिव therefore net force will be h minus t जदि इटा सेम डायरेक्शन था t टा ए डायरेक्शन एक्टिंग होता h plus t था therefore we can write net force here net force acting on horse forward force h minus backward force t से पहला minus h minus t काहे लिखा है h greater than t because horse moves forward not backward आगु को जाई करूची वे फोर्स ता ताठो अधिक जदि से टाणी परिबनी त माने बैकवर्ड फोर्स ता आगो फोर्स टू अधिक होइतो तेने जदि आगु जाई न पारे here net force acting on horse equals to h minus t in place of force we can write h minus t equals to ma equation number 1 horse moves forward if h greater than t if acceleration of the horse be a and mass equals to mass small a then according to Newton's second law we can write force equals to ma but here force equals to we can write here net force acting on a horse equals to H minus T. Therefore, in place of F, we can write H minus T. Students, understand? Not easy. Yes or no? Are you understand? Okay. Similarly, this is for a horse. Next for cart, you can say this is for horse. That is, we got H minus T equals to MA. Now for similarly cart, second case, cart. Cart moves forward. Cart moves forward if, who can say, tell me, who understand, answer it. जे बुझितो तो मित्र आंसर दे दो. कार का कितनी फॉरवर्ड मूवमेंट करिवो? कार मूव्स फॉरवर्ड इफ, who can say, tell me, the students tell me, who can say, when T greater than F, T force of tension, opposing force, T greater than F, नली आगु जीवन है. If T greater than F, if next, if acceleration of car B small a and mass of car B capital M, then जदि कार एक्सीलरेशन घोड़ा आगु जेंति जीवो कार मध्ये सेंति आगु जीवो तमने एक्सीलरेशन ऑफ कार इज सपोज ए एक्सीलरेशन मास कैपिटल M, then force equals to we can write then force F equals to mass into acceleration. Here mass small m, here mass capital M. Now similarly here net force acting on cars, who can say, tell me, net force, here net force acting on cars, who can say, tell me. Very good, very good. We can write forward force, Kannada forward, car moves forward, that is T greater than F, therefore T minus F. Direction of force towards this, two forces acting. Suppose this is a body, here direction this acting force F1, this is F2. Net force will be F1 plus minus F2. F1 plus minus F2, that is F1 minus F2. In similar way, we can write here net force acting on car equals to T minus F. Therefore, this expression becomes good values In place of f, put values t minus f equals to ma. Equation number 2. This is for a horse. Horse moves forward. H minus t equals to ma. Expression. When cart moves forward, expression t minus f, h minus t minus f, h minus t minus f, h minus t equals to ma, t minus f equals to ma. Small m, capital A. Suppose this is equation number 2. Students, all of you write, please chat. Please chat. Okay. Next. Now adding equation 1 and 2. Now adding equation 1 and 2. Now adding equation 1 and 2. समीकरण 1, समीकरण 2. समीकरण 1 2 को एडिशन करा. We will get addition कले हमें कौन पाएगा? h minus t plus t minus f plus t minus f. LHS left hand side addition h minus t plus t minus f. Right hand side ma plus ma. Now solve. Plus t minus t cancel, plus t minus t cancel. H minus f equals to, this is a term, in both term common is a, taking as common a, m plus n. Next step, a common, capital M plus small m. Now finding acceleration, horse and cart problem. Finding acceleration, a equals to h minus f by students understand? Yes or no? Easy, very easy. बुझी गले बहुत सहज. Here acceleration equals to h minus f divided by m plus f. Very important part. Conclusion. Suppose when acceleration is positive, we can say when acceleration is positive, केते बेले acceleration टा positive होबो, that is when h minus f is positive. यानी acceleration टा positive केते बेला होबो ना जेते बेले h माइनस इटा तो दीटा प्लस मास सब बेले positive. h minus f जेते बेले positive होबो सेते बेले acceleration होबो positive. जेते बेले इटा नेगेटिव आसीबो सेते बेले acceleration ना नेगेटिव. रिटार्डेशन घोड़ा आगु जाउ नथिबो, घोड़ा आगु जाई परिबो नै. रिटार्डेशन when केते बेले acceleration is positive, now when h minus f equals to positive or h greater than f, h greater than this force. Look at this. Stream force of tension backward, stream force of tension forward. Same object. Action, reaction. Same. This is a body. Suppose a force is acting. Suppose this is a body. Suppose a force is acting 50 Newton towards this. Another force 50 Newton towards this. In this case, if this is a same body, then same force equal and opposite direction, then they should be cancelled. That is net force should be 0. Here one is forward, other is backward. समस्ते बुझिलो कि आगु जिबा? Yes or no? Clearly? Students clearly बुझिलो? Okay. Next. Next one is weight of a man. Most important topic in physics, laws of motion. Laws of motion of this part is very most important. Weight of a man in an elevator or lift. That is the apparent weight. Apparent weight of a man in an elevator or lift. Elevator कहबा जा, lift कहबा से lift इतलो ऊपर को जाउथिबो, apparent weight कोन हुए? Lift downward movement कले apparent weight कोन हुए? Lift ता तुम्हारा upward हो कि downward हो, जदि uniform velocity किंबा रेस्ट अवस्था रे थिबो ताले apparent weight रे कोन परिवर्तन घटे? नाइ लिफ्ट इज सडनली ब्रेक डाउन हो ताले apparent weight रे कोन परिवर्तन हुए? 4 cases. One by one studied. First case, maybe lift moving upward. Suppose this is a lift moving upward. Case 1. First case, when lift moves upward direction. Underline all of you. Case number 1. If lift moves upward direction. मने करो पिला माने एटा ओटे लिफ्ट अछि, ए लिफ्ट रे 500 जन 5% कि 10% अछंती. लिफ्ट ऊपर ऊपर जाउछ. तने से लोक माने लिफ्ट भीतर जे थिबे सेमानकर वेट संबंधी तथ्य से माने कोन अनुभव करथि, कोन फील करथि, सेमानकर वेट ऊपर से कोन स्टडी करथि. आर यू नो? यस और नो? तुमे तले लिफ्ट रे ऊपर जाउछ कोन फील करछ? Apparent weight. Tell me. Are you know or not? Here, weight acting downward, entire weight. Here an entire weight acting downward and a reaction. This is action and this is reaction. Lift plus person, entire weight acting downward and the reaction are upward. Since here lift moves upward direction, therefore we can write, that means हमको बुझिବାକୁ होगा R is greater than mg. R is greater than mg. ଯଦି R ଟା mg ଠୁ ଅଧିକ ହୁଅନ୍ତା ନାହିଁ ତାହେଲେ ସେ ଉପରକୁ ଯାଆନ୍ତା କି? कारण उपरକୁ ଯାଉଛୁ ତ ଇଆଡୁ ଯାଉଛୁ ତ R value ଟା R should be greater than mg. যদি স্थिर होता তাহলে R equals to mg. যদি এটা ডাউনওয়ার্ড যাতা mg minus R তাহলে mg greater than R. eso মনে রাখো upward যাଉଛି মানে R ভ্যালু টা আট দিব. স্টুডেন্টস বুঝিলা না বুঝিলানি? First case, when lift moves upward, suppose this is weight and this is reaction. Therefore mass is small m, acceleration a. When lift moves upward direction, that is when acceleration of lift be a and mass be small m, then we can write upward this minus this, R minus mg, this is force, net force acting on lift, R minus mg. R minus mg equals to ma, or we can write net force equals to net force acting on lifts equals to F equals to ma. Therefore we can write in place of F we can write R minus mg. R minus mg equals to ma. That implies R equals to mg, this is minus, transpose right side plus ma. That implies R equals to a whole into g plus a plus students understand? Yes or no? Please chat yes or no. Conclusion is that is conclusion. In this case that is when lift moves upward direction, apparent weight of a man increases Underline it. All of you right? Yes or no? Case 2, second case. Second case, when lift moves downward direction, what will happen? Based on apparent weight, second case, if this is the lift, weight acting downward, reaction upward, lift moves downward, that means acceleration towards downward. Acceleration is here. Acceleration since lift moves downward, what can I write? Value of mg greater than r. mg greater than r. That is, we know net force F equals to ma mass m acceleration a. Force equals to mass into acceleration. That implies net force acting will be, since mg greater than r, therefore net force will be mg minus r. Net force will be mg minus r. Now, in place of F, we can write mg minus r. In place of F, net force mg minus r. mg minus r equals to ma. That implies minus r transpose right side, ma transpose left side. That is, mg minus ma equals to r. That implies arrangement r equals to m whole into g minus a. This is a term, this is a term. In both terms, taking as common small m, r equals to m whole into g minus a. Negative side. Conclusion: when lift moves downward, apparent weight of a man decreases. All of you right? Tell me. Chat please. Yes or no? Students, yes or no? Please chat. बोथ पार्ट दीटा काम तुम्हें करियो लेखिबा सहित बुझिबा दरकार केस 3 थर्ड केस Case 3 when lift moves downward or upward maybe downward maybe upward माने लिफ्ट ऊपर को जाई पारे कि तळ को जाई पारे दीटा केस जहां भी हो ऊपर को जाओ कि तळ को जाओ when lift moves bracket downward or upward moving with uniform velocity underline uniform velocity or rest well lift rest अवस्था थिबो दीटा सिचुएशन एडी आसी गला केस 3 रे दीटा सिचुएशन आइतर लिफ्ट रेस्ट अवस्था रे थाई पारे किंबा यूनिफॉर्म वेलोसिटी रे थाई पारे यूनिफॉर्म वेलोसिटी तिले केमति थिबो आइतर अपवर्ड और डाउनवर्ड रेस्ट तिले से सिद्ध रहितो तले ई केस रे कोन प्लान देखो फर्स्ट केस देखो एडी इंक्लूडिंग बुझे दुजीटा दीटा सिचुएशन अछि जदि लिफ्ट रेस्ट अवस्था रे अछि when lift is at rest that is weight acting downward reaction upward your rest means balanced r equals to mg के का सहित कम अधिक किछि नाही r equals to mg तुने से ऊपर को जाउनी कि तळ को जाउनी तुम तार मोमेंटा अपवर्ड नुहे कि डाउनवर्ड नुहे तले ई केस रे कोन लिखबा अच्छा डाउनवर्ड रे कोन लिखितिले यू कैन से डाउनवर्ड में कोन लिखितिले r equals to a whole into g minus a और ये लिखितिले किलाने देखो r equals to mg minus ma but here r equals to mg that is we can say here no acceleration since it is rest acceleration equals to 0 therefore this term entire term 0 therefore r equals to mc देखना नहीं देखो check it r equals to mc this is a situation of rest second case for a uniform velocity expression r equals to mg minus ma maybe upward or maybe downward से जाओ ना कहीं जदि यूनिफॉर्म वेलोसिटी अछि तला एक्सीलरेशन ना कोन जे कोन सोड बॉडी जतुले यूनिफॉर्म वेलोसिटी रे थिबो एक्सीलरेशन शुड बी 0 if a body moving with uniform velocity then हमको बुझबा को हो एक्सीलरेशन शुड बी 0 से वस्तुर त्वरण एक्सीलरेशन ना हो 0 therefore r equals to mg minus m into 0 since moving with the uniform velocity acceleration equals to 0 something into 0 0 therefore r equals to mg सेठी में here r equals to mg here r equals to mg एनो ये डेटा का सिचुएशन केस 3 रे रिप्रेजेंट करा जाय Uniform velocity R equals to mg. Rest R equals to mg. Understand? Students understand, yes or no? Tell me. अरे 100% बुझছো तो 100%. Last case. Last case. Case 4. Last case. When lift suddenly break. When lift suddenly break. लिफ्ट ऊपर को जाउची कि तळ को जाउतिला सडनली ब्रेक खसी पड़िबो. अपरेंट वेट कोन हुए ए पूर्व केस ता थिला केस रे r इक्वल्स टू mg माने अपरेंट वेट सेम किछि नाइदर इंक्रीज नॉर डिक्रीज सेम. केस 3 केस 1 अपवर्ड अपरेंट वेट इंक्रीजेस. केस 2 लिफ्ट मूव्स डाउनवर्ड अपरेंट वेट डिक्रीजेस. Rest unchanged, uniform velocity unchanged. Case 4 when lift suddenly break. Suddenly break हो माने खसी पड़ियो माने ऊपर खसी माने तळको सबले खसियो. एटा को मुंडरे मन रख. Suddenly break lift जदी suddenly break हो weight acting hela downward. That is we know for a downward जदी lift का downward movement करछि we know expression r equals to mg minus ma. केस 2 डाकले माने टिके देखो जेते बेले लिफ्ट टा मूव्स डाउनवर्ड सेतले एक्सप्रेशन थी r equals to mg minus ma. therefore इस सिचुएशन जेते सडनली ब्रेक होबो कोन घटिबो सेते बेले ना r equals to mg minus we can say लिफ्ट सडनली ब्रेक होबा अर्थ बुझियो पिला माने एठारे ए लिफ्ट आ जो भीतरे पर्सन माने थिबे लिफ्ट टा जो रेट रे पड़िबो लोक माने मध्ये से रेट रे पड़िबे. दैट इज सिंगल टर्म कनेक्टेड इट हैव एक्सीलरेशन टर्म रहिबनी. दैट इज एक्सीलरेशन ड्यू टू ग्रेविटी. एक्सीलरेशन टा कन्वर्सन होई जिवो एक्सीलरेशन ड्यू टू ग्रेविटी. दैट इज ए टा हेला mg minus mg और एमटी मध्ये लिखिबो इन बोथ टर्म m will into g minus a. That is m equals to g minus g, that is 0. Here also 0, here also 0. एमिति बुझिबो एमिति मध्ये बुझिबो सेम. ता माने लिफ्ट रे जदी लिफ्ट ता सडनली ब्रेक होबो ता भीतर जो लोक माने थिबे वेटलेसनेस माने तांकु लागियो आराम रे हमें उडुछु आकारे वेटलेसनेस ओजन बीन weightlessness से मैंने फील करिवे weightlessness. First increases, second case decreases, third case neither increase nor decrease, fourth case result is weightlessness. Students understand, yes or no? ओके नेक्स्ट क्लास आगु जिबा जहा जिवो हला आज एटी स्टॉप हला बुझिला टेल मी all of you understand. Yes or no?